Okay, good morning, good afternoon. Today we're starting a new unit, and that unit is called Sequences and Series. Today we're going to have a bunch of note taking, okay? No assignment for today. But in your notes, go ahead and pause the video and write every single one of these definitions down. A sequence is a set of numbers with a particular order or pattern. So we're going to be looking at patterns. Each number in the sequence is called a term. This is from Algebra 1. This should not sound new. A finite sequence is a sequence with a limited number of terms. So for example, a sequence that starts at 1 and then it goes up by 1, 2, 3, 4, 5. So the pattern would be going up by 1 each time, but it stops at 5. An infinite sequence is a sequence with unlimited terms not ending. So an example would be 0, starting at 0, 1, 2, 3, 4, 5, and you'll notice the 3 dots. Those 3 dots is saying that this sequence is not stopping at 5, it is going on forever. Once again, in your notes, go ahead, pause the video, write this down, and then fill in the blanks when you're ready. So the first term is written as a sub 1. So I am going to say sub, S-U-B, a sub 1. Each subsequent term means like the next one. So each subsequent term is written as a sub n, where n is the term number in the sequence. So here's an example. I gave you a sequence, 1, 5, 9, 13, 17, and then the 3 dots say that it's not stopping there. The pattern goes on forever. Identify the following term values. So the first one I'm asking you to identify is a sub 1. So that's your first term. Well, our first term is 1, so we're just going to put a 1 right here. All right, the next one is asking for a sub 4. This is asking for the 4th term. So term 1, 2, 3, 4. Our 4th term is going to be 13. A sub 9. So this is asking for the 9th term. So 1, 2, 3, 4, 5. Looks like we're going to have to keep it going. So first we have to figure out what is the pattern here. How do we get from 1 to 5 and then the same from 5 to 9 and 9 to 13? Well, to get from 1 to 5, we add 4. Let's see if that keeps working. If I add 4 to 5, do I get to 9? Yes, I do. So it looks like we just keep on adding 4 to each one. So that means the next number in our sequence would be whatever 17 plus 4 is. And that would be 21. And then the next one after that would be add 4 again. So that would be 25. Add 4 again to 25, and we'll get 29. Is that our 9th term, I think? 1, 2, 3, 4, 5, 6, 7, 8. We got one more. Add 4 to 29. 29 plus 4 is 33. So a sub 9 is 33. And then a sub 12. So we need to go, I think, 3 more. So 33 plus 4 is 37. 37 plus 4 is 41. And then 41 plus 4 is 45. Let's just make sure that's our 12th term. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It is our 12th term. So that would be 45. Again, this is in your notes. Okay, notice up here, this is not in your notes. All I want you guys to do is just listen to this. So sequences as functions. Since each term value is paired with exactly one term number, a sequence is a function with the following properties. So the domain is the set of your term numbers. So I'm just going to write term numbers right here. Whereas the range is the set of our term values. In an infinite set, the domain is the set of all natural numbers. A natural number is a counting number. So that's like 1, 2, 3, 4, and so on. No decimals or fractions. Okay, next piece in your notes. In your notes. Make sure you copy this down, pause the video, and when you're ready, go ahead and press play. So we're going to learn what it means to be a recursive formula. A rule in which one or more previous terms are used to generate the next term. Previous terms is really important here. So a recursive formula is we use previous terms to find the next terms in our sequence. So one example is called the Fibonacci sequence. So the Fibonacci sequence is a recursive formula. What we're going to do is start with 0 and then add 1 to that. And then to find our next number, what we're going to do is we're going to add the 2 previous terms. So 0 plus 1 is 1. Now to find my next term, so to find this term right here, we would add our 2 previous terms together, just the 2. So 1 plus 1 is 2. To find the next term, we're going to add the 2 previous terms. So to find this guy right here, we're going to add 2 plus 1, which is 3. Let's keep going. So we add, to get to this term right here, we're going to add the 2 previous terms. 3 plus 2 is 5. Then we got, to find this term right here, we got 5 plus 3, which is 8. Next term, this term right here, add the 2 previous. 8 plus 5 is 13. Let's keep going. Next one, 13 plus 8 is 21. Let's go one more. To find this term, 21 plus 13, so that's going to be 34. And it can keep going on forever, so we're going to add 3 dots to say this could keep going on forever. I just don't feel like doing anymore. So what is our a sub 1? What is our first term? Well, that's easy. It's 0. What is our second term? Our second term is 1. The way that we would explain how to write this as a recursive formula, I'm going to write it down first, and then I'm going to explain what it means. So it is going to be a sub n minus 1 plus a sub n minus 2. Anytime we see an n minus 1, this right here, you're going to read that as the previous term. So anytime you see n minus 1, it's really saying previous term. I'll explain what that means tomorrow. And then this right here, if you see an n minus 2, that's not just your previous term. It's your second previous term. Okay, and because this is such a notes-heavy day, I asked you to write a lot. You have no assignment for today, and I will make sure you have your notes down. You have them ready for tomorrow. I will see you tomorrow.